Hello and welcome to my channel. In this video, we'll learn how to write ThreadSafe functions. We'll also write functions that we can bind to our chooser table. Then I'll also show you how to write functions that you can bind to your animation nodes. So let's get started. Okay, so let's start by adding our variables. So I'll make a public section, and in here I'll add these variables. So these are our variables that we need for now, but we need to update these every frame. So we'll add a function to do that, which will be something like this. It is a void function and I'm calling it setStateNodeData. Now this needs to be a ThreadSafe function because we'll be calling it inside our native ThreadSafe update animation function. So to make it ThreadSafe, all we need to do is this. Okay, so let's implement the setStateNodeData now. In here, we'll first save our character transform. Here we'll access our owner from our AnimInstance proxy, and then from the owner we'll access the actor transform. Next, we will set our velocity last frame as our current velocity, and then we'll set our current velocity using our proxy movement component, and we'll get the velocity from it. But we'll have to add these two variables. So I'll add two f vectors like this. Okay, next we'll update our direction and speed like this. So for direction, we'll use the inbuilt calculate direction function, and we'll set speed as the size 2D of our velocity. Next, we will set our last non-zero velocity as our current velocity if our speed is greater than 5. Now we are moving if our current and future velocities are not equal to 0. Next, we will be setting our is-strafing, crouching and sprinting variables like this. So we are accessing our character and the movement component using the AnimInstance proxy we defined in our last video. Lastly, we'll make sure that we have a valid post-search database, and if we do, we will set our database tags like this. Finally, we will set alpha, which is the blend time for our motion matching node. So if we are turning in place, the blend time will be 0.5, otherwise it will be 0.25. Okay, so we are done with our setStateNodeData function. Let's call it inside our native ThreadSafe update animation. So setStateData, and we'll pass in the delta seconds. Okay, now we need some more variables. So let me paste them here. Okay, so here we have a f post search query trajectory variable called trajectory that will be used by our pose history node. But at the moment, this trajectory is empty. So we need to generate this trajectory every frame. So let's write a function to do that for us. Again, this will be a ThreadSafe function because we'll call it inside our ThreadSafe update animation function. Okay, there we go. Now let's implement this. We will start off by creating a f post search query trajectory variable called outTrajectory, and we'll use this to store the result of our post search generate trajectory function. Next, we will create a collision result of type f post search trajectory world collision result, and we'll create an array of actor pointers for the ignored actors. Then we can call the handle trajectory world collision function, and as the name suggests, the collision result will store the result of this function. Once this is done, we will sample our trajectory at 0.5 seconds and 0.4 seconds. Finally, we will calculate our future velocity as the difference in the position component of our two samples times 10. Okay, so our generate trajectory function is done. Let's call it inside our native ThreadSafe update animation. Generate trajectory, and we'll pass in delta seconds. Done. Now let's write our chooser table functions. To be able to bind functions to our chooser table, the functions need to fulfill some criteria. They need to be blueprint callable, they need to be thread safe, they need to return some value, so they cannot be void functions, and they need to be const functions. For our system, we'll need these 4 functions, and all of them will return booleans. So let's start implementing them one by one. For is starting, we'll first make sure that we have a valid movement component. Then we will check if our future velocity is greater than or equal to our velocity plus 100, and if we are not pivoting. For is pivoting, we will first make sure that we have a valid movement component, and then we are pivoting if the absolute value of the yaw component of the delta rotator between the future velocity rotation and the current velocity rotation is greater than or equal to 45 degrees. Next, we should turn in place if the absolute value of the yaw component of the delta rotator between character transform dot rotator and root transform dot rotator is greater than or equal to the max turn angle, which is set to 90 for now. Lastly, we should play a spin transition if the absolute value of the yaw component of the delta rotator between character transform rotation and root transform rotation is greater than or equal to 130 and our speed is greater than or equal to 150 and our current database tags array does not contain the pivot tag. Okay, so our chooser table functions are also done. While we are here, let's also write functions to calculate our yaw and pitch for our aim offsets. So for return yaw, we will do this. So basically our yaw is the delta rotator between our controller rotation and our root transform rotation clamped between -90 and 90. And for our pitch, we'll do this. So we'll return the pitch component of our get base aim rotation. In our game animation sample project, if we take a look at our motion matching node, we'll see that there are two functions that are bound to it. So to be able to bind functions to our anim nodes, we need to do this. So it needs to be a ThreadSafe function, and the function needs to take two parameters, a f_anim_update context and a f_anim node reference. Now for our purposes, we'll need these three functions. These two will be bound to our motion matching node, and this is for our turn in place. For update motion matching movement, we'll first make sure that we have a valid chooser table, and then we'll convert this node into a motion matching node and we'll make sure that the conversion was successful. Then we will evaluate our chooser table. Now we need to cast this because the evaluate chooser function returns an U object, but our later functions would need a post search database, so we have to typecast it here. Lastly, we'll just set database to search like this. Now for motion matching post selection, just like before, we'll convert this node into a motion matching node and we'll make sure that the conversion was successful. Next, we will create a variable of type f post search blueprint result and a boolean called isValidResult. Lastly, we'll call our get motion matching search result function and we'll set the selected database like this. Okay, the functions for our motion matching node are done. Now let's do the turn in place. So here we'll do this. So basically what we are doing is we are adding 90 degrees to our yaw to account for the fact that our character mesh is rotated 90 degrees in our blueprints. Okay, so our turn in place function is also done. Now for our blend stack graph, we need these variables and these two functions. Okay, so let's implement these. Let's start with the update blend stack function. So in here we'll do this. So what we are doing is we are storing anim time, anim asset, and we are either enabling or disabling orientation warping based on whether or not our animation sequence has this curve. So now since our return target orientation function returns a f_quad, it needs to be a const function. So for this function, we will sample our trajectory at 0.5 seconds and return the facing. So this is it for this video, and in the next video, we'll bring this all together in blueprints and complete our locomotion system.